Hello everyone, this is Gaurav Mishra and you are watching GM Physics and I welcome you all. Alright, so in this video lecture, we are going to learn representation of vectors. What is representation of vectors? How do we represent a given vector? How do we denote a vector? So we have two ways of representation of vectors. One is symbolic representation of vectors, and second is mathematical representation of vectors. Under mathematical representation of vectors, we'll be learning two forms. One is polar form, another is rectangular coordinate form. So let's begin. Symbolic representation of vectors. Symbolic representation. From the name itself, we understand using a symbol to represent a vector means we have to use certain symbols or a symbol which represents a vector quantity. And we know a vector has both magnitude and direction. So your symbol should also be sufficient to represent both magnitude and direction. So the symbol which can fulfill both of these things means representing a numerical value, a magnitude, and showing a direction, that is an arrow. So we'll use an arrow to represent a vector. So let's draw an arrow. So this arrow is used to represent a vector quantity. How? It must be able to represent both magnitude and direction. Let's see. The length of this arrow from its tail to its head, it represents the magnitude of the vector. We'll just see how it represents. So this length represents the magnitude of the vector. The length of the arrow represents the magnitude of the vector, right? And the orientation of the arrow or the direction of this arrowhead, this represents the direction of the vector. The length of the arrow is used to represent the magnitude of the vector, and the direction of the arrowhead or the orientation of that arrow shows the direction of the vector. Let's see to make it more clear. Suppose this is a block which is lying on a horizontal surface and it's being pulled with the help of a string. Let's say it's pulled with a force of 10 Newton. And this string is at an angle of 30 degrees with respect to horizontal. So force is a vector quantity. So a force of 10 Newton is acting on the block along the line which is inclined at angle 30 degrees with respect to the horizontal. So we can represent this vector quantity by using a symbol, by using an arrow. How? Just look at this. Rather than using this string and hand and writing 10 Newton and showing 30 degrees, we can simply make this block and we'll draw an arrow of 10 units at an angle of 30 degrees. This becomes my force vector. This becomes my force vector. It represents the force. So here we are using an arrow to represent 10 newtons along 30 degrees with respect to horizontal. So let's write it here. I have drawn an arrow of 10 units oriented at an angle of 30 degrees with respect to horizontal. This represents my force vector, right? Its length represents 10 units, that is 10 newtons, and its direction shows the direction of the vector. Now the question is, am I required to draw the arrow of exactly same length as of the magnitude of that vector? No, not necessary. You have to draw the length proportional to the magnitude of the vector. Like, for example, for 10 newtons, you can draw an arrow of 1 centimeter, but you will have to define the scale that I have chosen 1 centimeter equal to 10 units of force, right? So that scale is completely our choice. We can make it 1 centimeter is equal to 10 newtons, or 2 centimeter is equal to 10 newtons, or 1 inch is equal to 10 newtons. It's completely your choice, but it must be, the length of the arrow must be proportional to the magnitude of the vector. Conceptually, this should be done. But in all practical purposes, we are not required to take the scale and measure the length of the arrow and make it proportional to the magnitude of the vector. Means we are not required to do like this. Suppose I have to represent 20 Newton force along the same direction. I am not required to take the scale and measure the length to be 2 centimeter according to my choice of a scale, right? I have chosen 1 centimeter is equal to 10 newtons. So for 20 newtons, I'll be drawing an arrow of 2 centimeter length, but it is not required. In all practical purposes, we are not required to do like that. But conceptually, the length of the arrow, the length of the arrow is directly proportional to the magnitude of the vector. The length of the arrow is directly proportional to the magnitude of the vector, and the orientation of the arrow is along the direction of the vector, Can be a displacement vector, velocity vector, force vector, a torque vector, angular velocity vector. Whatever vectors you have, all of them will be represented by an arrow. So the magnitude of the vector will be represented by the length of the arrow, and the length will be directly proportional to the magnitude of the vector. The scale is completely your choice. Now, orientation of the arrow. You have to keep or direct the arrow exactly in the direction of the vector. Like here, the block is being pulled with 10 Newton along the line which is making angle 30 degree with respect to horizontal. So you have to draw the arrow along this line itself, making angle 30 degree with respect to horizontal. Now, how do we denote a vector? So we use a shorthand method of denoting that vector. So what we do, we choose a letter. In most cases, the first letter of that given vector quantity. For example, here it's force vector. So I choose F, whether a small letter or capital letter. So I'll choose F and put an arrow at its top. This will represent my force vector. You can say a symbolic representation, or this is the way how we denote the vector. That arrow shows that this given quantity has some different property as compared to other quantities which we deal with in our day-to-day lives. For example, we write temperature as capital T. We write mass as capital M. We don't put arrow at its top. But this force is a physical quantity which has some properties different as compared to these quantities like temperature and mass. And we already know it's a vector quantity, it has direction. That's why we put an arrow at its top. It shows that this quantity has direction as well, means it's a vector quantity. So what we do, we take the first letter. In most cases, we take first letter. For example, for force, we take F. For velocity, we take V. For displacement, in many books we write it as d. At many other places we see it as s vector s, and at top we put an arrow. For example, acceleration, we write a, and at its top we put an arrow. So what you have to do, you have to take a letter. It's not necessary you have to take the first letter. In most cases it is taken. It's completely your choice what you want to choose for representing that given vector. But you have to put an arrow. Whether you represent force by F, or you represent by a small f, or you represent by x, if it's a vector quantity, you'll have to put an arrow at its top. And one more thing, this arrow only represents that this is a vector quantity. It doesn't show the direction. Means if the vector is acting along this direction, I won't put arrow like this. If the vector is acting in vertically downward direction, I won't put the arrow at F in vertically downward direction. It has to be placed the same way irrespective of the direction of the vector. So I hope now you have understood what is symbolic representation of vector. So symbolic representation is simply you have to take an arrow. The length of the arrow will represent the magnitude, and the orientation or the direction of the arrowhead will be the direction of the vector. How do you denote the vector? You take a letter. In most cases, you take the first letter and put arrow at its top. So this is symbolic representation of vectors. So now suppose a car is moving along east direction with a speed of, let's say, 80 kilometer per hour. So we can represent this vector quantity, that is velocity vector of this car, which is 80 kilometer per hour in magnitude and along east direction. So this 80 kilometer per hour is the magnitude of this vector quantity, and along east is its direction, right? So we can write v vector can be written as 80 kilometer per hour, 80 units along east, right? Now, if you want to denote the magnitude and the direction separately, so what symbol do we use for that? How do we denote magnitude and direction separately? So we write the magnitude like this, taking the vector quantity and putting mod on it. So mod of v vector represents magnitude of the vector. For representing the magnitude, you have to put two straight lines on either side of the vector. So for here, velocity vector, I have placed two lines. That is called mod of velocity vector, magnitude of the vector, that is equal to 80 kilometer per hour, right? And if we want to represent the direction, we write v with cap, v cap. This represents the direction of the velocity vector. So that is along east, right? So if you want to represent only direction of that given vector, you'll put a cap on that letter. So for velocity vector, v cap, for force vector, f cap, for acceleration vector, a cap, and so on. One more thing, for magnitude, we generally represent it like this, mod of v vector, but we can also use only v, right? For force vector, if you want to write the magnitude, you can use only f. For acceleration vector, if you want to write only its magnitude, you can write a. For example, in this case, I can write v is equal to 80 kilometer per hour. All right, so this is all about symbolic representation. We use an arrow to represent a vector. How? So the length of the arrow represents the magnitude. The direction in which it is headed shows the direction of that given vector. The length of the arrow must be proportional to the magnitude of the vector. It must be drawn to a scale, and the choice of a scale is completely yours. But we are never required to draw to a scale in most of the practical cases. It's never required. You can draw a rough diagram, a freehand diagram in almost every case. It's not required at all. but conceptually, the length of the arrow is proportional to the magnitude of the vector. And how do we denote a vector? So we take a letter and put arrow on its top. And in most cases, we take the first letter. You can take any one. How do we represent the magnitude of the vector? So we use mod for that case, or simply the letter without arrow on its top, right? And how do we show the direction of the vector? So we put cap on it. So for velocity vector, v cap, for force vector, f cap, and so on. So I hope you have understood symbolic representation of vectors. All right. So the symbolic representation of vectors is not sufficient. There are many situations, many instances where we are required to perform mathematical operations on vectors. So just representing the vectors in its symbol form will not be enough to deal with such situations where we are required to perform mathematical operations on vectors. So we need to represent vectors mathematically. So for that purpose, we have two forms of representation, two forms of mathematical representation of vectors. One is polar form representation and one is rectangular coordinate form representation. For both of these, we are required to have a good understanding of what is a Cartesian coordinate system or rectangular coordinate system. So if you don't understand what is a Cartesian coordinate system or a rectangular coordinate system, both are same thing. So kindly check. I have provided a video in the link of this video lecture. So just check that video, understand it, and then return to this video. All right. So first of all, polar form representation. So whether it is polar form representation or rectangular coordinate form representation or symbolic representation, doesn't matter. They all should have two components, one for denoting magnitude and the other one is for direction, because we are representing vectors, right? So it is very much expected that in polar form also, we will have two components in the representation, one for magnitude and one for direction. So let's take an example and try to understand what is the polar form representation. How do we represent a vector in polar form? So polar form representation is given in this form. Look at this. For let's suppose a vector b is given. So b vector is written as L theta. This is the standard convention of representing polar form of a vector, where this first variable is used to denote the magnitude of the vector. This is used for the magnitude, and this one is used for the direction of the vector. This will become more clear as we take an example. Let's take an example and try to understand it more clearly. Suppose a force vector is given like this: 50 units, 30 degree inside the bracket. I assume you are understanding what 50 means and what is 30 degree in the polar form representation. This 50 units is the magnitude of the vector. Means here we have taken force vector, so it is 50 newtons, and 30 degree represents the direction in which this force is acting. So this F vector is equal to 50, 30 degree simply means we can draw an arrow of length which is proportional to the magnitude of the vector, that is 50 newtons. We already know about this, we have already discussed. And we will make an angle of 30 degree with respect to horizontal. Now the question is, where is the reference? Why should we make an angle 30 degree with respect to this horizontal line? And why only in this sense? Why can't I write or draw this vector making an angle 30 degree in this direction? Why not? exactly true question. So let's make it completely clear in this discussion. For this, we require a Cartesian plane. And here I have already drawn the Cartesian plane. This is positive x-axis, this is negative x-axis, this is positive y-axis, this is negative y-axis. You are already familiar with Cartesian plane. So this 50 here or L here, there is no confusion. It simply represents the magnitude of the vector. So there is no confusion at all. But this theta, this 30° here creates a confusion. Here we don't know with respect to which line we have to draw this 30°. And suppose this is the line. Let's suppose that this is the line. Then whether 30° in this sense or in this sense, where we have to go 30°. So this is the problem that has to be solved. Once this is solved, we understand what is the polar form representation and we'll be able to represent the vector in polar forms easily. So look at this. I'm talking about this theta. I'm talking about this theta. That is the problem. That is the problem causing thing here. So that theta you have to measure with respect to a standard reference line, that is positive x-axis. The angle has to be measured with respect to positive x-axis only. That is the standard reference that is worldwide accepted. You don't have to be confused that which line should I choose for drawing that angle 30° or any angle in general, whether 60°, 150°, 120°, whatever. So keep in mind that this is the standard reference that you have to measure the angle with respect to positive x-axis. So let's write it. So theta is measured with respect to positive x-axis. Now the question is, in what sense? Whether I should measure 30° in this sense, that is anti-clockwise, or in this sense, clockwise. So for this, we have a proper sign convention. Here it is written plus 30°. When it is plus, then you have to move in anti-clockwise sense. Anti-clockwise means plus. And if it is given negative, then you have to move clockwise with respect to positive x-axis. Means if it is given plus 30°, then you have to go 30° anti-clockwise. Then you have to draw this arrow, which will represent this vector, and it's of magnitude 50 units. So here it is 50 Newton oriented at an angle of 30°. So for this one, this is the representation. If it is given, for example, let's say 30 Newton minus 90°, let's say. Minus 90 means in clockwise sense you have to move. By what angle? 90°. What is the magnitude of the vectors? 30 Newton. So you have to go 90°. You have to go 90° in clockwise sense. And then you have to draw an arrow which will represent how much magnitude? 30 newtons. So this is the second vector. Let's call it F1 vector and let's call this F2 vector. So this is my F2 vector and this is my F1 vector. So in polar form representation, now you understand the first variable is for magnitude and the second variable is for direction. The direction variable has to be handled with care. It has to be measured with respect to positive x-axis only. And what is the sign convention? If positive angle is given, then you have to move in anti-clockwise sense. Anti-clockwise is for positive, right? And you have to move in clockwise sense, if the sign of the angle is given negative, right? Let's take an example and use whatever we have learned for polar form representation. All right, so let's take an example to understand what we have learned in polar form representation. So for representing these two vectors which are given in polar form, first of all, simply draw the rectangular coordinate system. So this is my plus x, this is minus x, this is plus y, this is minus y, right? The first vector, v1 vector, is given as 100, 120 degree. Whatever be the vector, doesn't matter. We have to understand 100 as the magnitude of the vector and 120 degree as the angle with respect to positive x-axis. And here it is plus 120. So we have to go in anti-clockwise sense by 120 degree. So I am going to 120 degree first, then I'll draw 100 units. So this is 90 plus 30. So approximately in this direction. So this is my vector. This is 100 units oriented along 120 degree anti-clockwise with respect to positive x-axis because it is given plus. Now if, and let's write it v1 vector. Now let's look at v2 vector. v2 vector is 200 minus 240 degrees. So first of all, we have to move 240 degree. And since it is negative, so we have to move in clockwise sense with respect to which standard reference line? Positive x-axis. So let's move 240 degree. So this is 180 plus 60, 240 means we come exactly along v1 vector. And since it is 200, so we will draw the length exactly double of this. So this becomes my v2 vector. So now I hope you understand how to represent a vector in polar form representation and what each of those components mean, L and theta, and how you have to measure theta. Theta you have to measure with respect to positive x-axis. If the angle is given positive, you have to move in anti-clockwise sense. If it is given negative, you have to move clockwise sense. So this is polar form representation. All right. So now we are going to represent a vector in rectangular coordinate form. From the name itself, you understand that we are going to use a Cartesian plane or a rectangular coordinate system for representing the vector. So for understanding it clearly, let me begin with locating a point in Cartesian plane. And from there itself, we will link it to rectangular coordinate form representation of that. So look at this carefully. Suppose there is a point in the Cartesian plane, right? And let's call it P. First of all, I want to locate this point exactly. For that, I need to find its coordinate. So let me drop a perpendicular on x-axis and measure this length from the origin. Suppose it is 4 units. This is 4 units. This is my origin, intersection of positive x-axis. Sorry, the intersection of x-axis and y-axis. Again, drop a perpendicular from point P to y-axis and measure this length from the origin. Suppose this is 3 units, right? So my point will be 4 units x-axis on x-axis and 3 units on y-axis. Since it is plus 4 plus 3, so we know it will be in first quadrant. Now suppose I place an arrow starting from the origin and ending at point P. Means the head of the arrow is at point P, whose coordinates are 4 and 3. Now let's see if it is possible to find the length of this arrow and the orientation of this arrow. So if we can find the length of an arrow, if we can find its orientation with respect to a reference line, then we can use this arrow to represent a vector quantity. So that is what we are going to see. First of all, I am going to calculate its length. So this is 4 units. This one is 4 units, and that represents the x coordinate of point P. Similarly, this one is 3 units, and that represents the y coordinate of point P. And this x and this y, they are perpendicular to each other. So this is angle 90 degree. And this arrow starts from the origin, ends at P. Let me call this point as A, where I have dropped a perpendicular on x-axis from point P. So this is point A, right? Where I have dropped a perpendicular from point P on positive x-axis. So from here you can see O, A, and P is a right angle triangle, and AP is the perpendicular, and OA is the base of this right angle triangle. So we can calculate OP, that is the length of the arrow, because it is hypotenuse of this right angle triangle. So we can use here Pythagoras Theorem. So let's find the length of the arrow. Simply using Pythagoras Theorem, we can calculate this. It is sum of square of base and perpendicular, p square plus b square, root of that. So p square means 3 square plus b square means 4 square. So how much is that? 3 3s are 9, 4 square 16, that is 25, root of that, it's 5 units. So it's possible to find the length of the arrow. Let me write it here. It's 5 units. So one purpose is solved for representing a vector, that is the length of the arrow is calculated. So we can find the length of the arrow if we know the coordinates of the head of the arrow, right? And the length of an arrow represents the magnitude of the vector. So we can represent the magnitude at least till now. Now let's see, we can find the direction, the orientation, the angle with respect to positive x-axis. So this angle, let's call it theta with respect to positive x-axis. Let's see if we can find angle theta. So for this, since triangle OAP is right angle triangle, here we can use the concept of trigonometry. I want to find theta, so I can use tan theta, because we know perpendicular and base. Perpendicular is 3 units and base is 4 units, right? So tan theta is P by B. Perpendicular 3 units, base 4 units. Tan theta is 3 by 4. It means theta is equal to 37 degree. So we have calculated the orientation of the arrow as well, just by knowing the coordinates of the head of the arrow. It means if you know the coordinates of the head of the arrow, you can find its length, you can find its orientation with respect to the standard reference line, which is the positive x-axis. So it is possible to use this method to represent a vector. And this is what we call rectangular coordinate form. But let's look in detail. What does these coordinates, this 4 and 3, really mean from a vector point of view? Till now, we have seen it as coordinates, rectangular coordinates of point P. But now let's look from vector point of view. What does these coordinates really mean for a vector? Now, before going any further, let's try to understand a very important point. Suppose this is my x-axis, this is y-axis, this is the origin of the Cartesian plane, and this is the vector, the same vector, right? Suppose a light is allowed to fall on this arrow perpendicular to x-axis. So we understand the image will be formed between these 2 points, this and this. The head will be formed here at this point. This point will be formed here. This point will be formed here, and so on. So the entire image of this arrow along x-axis will be contained between these 2 points, right? This is the projection of the vector along x-axis. And this we call the x component of the vector. In the previous one, where we saw 4 units, this 4 units, this is effectively the x component of the vector, right? Similarly, if we allow the light to fall on this arrow perpendicular to y-axis, then the image will be formed between this point and the origin, and the entire image along y-axis will be contained between these two points, right? This is called the y component of the vector. Let me write. This is x component of the vector, and this is y component of the vector. So what we called as the coordinate of the head of the arrow, they are effectively the projection of the vector, the projections of the vector along x-axis and y-axis respectively, which we call the components of the vector. That is, the one along x-axis, this is called x component, and the one along y-axis, that is called y component. So now the coordinate of the head of the arrow, we will call it the component of the vector, and we will not call it the coordinate of the head of the arrow. Now we have to look it from the vector point of view, right? So now the big question is how to represent the vector. So now see, I'm going to represent that vector in rectangular coordinate form. Means we have to write this vector in its rectangular coordinates, or its components, or its projections. So for this case, I'm writing the vector. Let's call it A vector. Just for convenience, I'm taking it as A vector. So A vector is equal to 4 units along positive x-axis. So I'll write along positive x-axis, right? And 3 units along positive y-axis. So I'll write and 3 units along positive y-axis, right? This does not look good. This is not a perfect representation, and we won't keep writing along plus x, positive x-axis along positive y-axis. We won't keep writing. This is lengthy, time consuming. So rather than saying positive x-axis, I'll call it plus I cap. This is the standard convention. Plus I cap simply means along positive x-axis. Similarly, minus I cap simply means along negative x-axis. Similarly, positive j means along positive y-axis, and negative j means negative y-axis. It should not create any confusion or any complexity in your mind. Simply, rather than saying along positive x-axis, we are calling it positive I cap. Rather than saying along negative x-axis, we are calling it negative I cap. Same, positive j cap, negative j cap, right? So rather than writing 4 units along positive x-axis and 3 units along positive y-axis, we write it as 4 I cap plus 3 j cap, right? This is the x component of the vector, and this is the y component of the vector. So this is an example of rectangular coordinate form representation of a vector. In general, we can represent as x component, y component. Means we can write any vector, v vector, as component along x-axis. I'm writing in general. Whatever will be the value, will be writing it. So I can write x I cap plus y j cap. This is the general representation of a vector in rectangular coordinate form, where this quantity represents the x component of the vector, x component, and this quantity represents the y component of the vector. The vector can lie in any of these quadrants: first quadrant, second quadrant, third quadrant, fourth quadrant. Accordingly, the x component can be positive, negative. The y component can also be positive, negative. For example, if a vector is in second quadrant, If we project it along x-axis, we will get a negative x component. And if we project it along y-axis, we'll get positive y component. Similarly, in third quadrant, if we draw a vector and we project it along x-axis, so we'll get a negative x component. And if we project it along y-axis, we'll get a negative y component, right? So whatever be the quadrant, whatever be the direction of the vector, if we know the components of the vector, we can easily find its magnitude and the direction, right? So what is a rectangular coordinate form representation? We represent a vector in rectangular coordinate form in terms of its components or in terms of their projections. Or you can simply say in terms of the rectangular coordinates of the head of the arrow, such that the vector's tail is at the origin of the rectangular coordinate system. So we write the vector like this. I'm writing a general form. V vector is equal to xi cap plus yj cap, right? Where this is the x component of the vector or projection along x-axis, and this is y component of the vector, that is projection along y-axis. The x component and the y component both can be negative and positive depending on in which quadrant a given vector lies, right? We will look at some examples. It will make it more clear. So suppose this is my y-axis, this is my x-axis, this is x-axis, and this is y-axis. And for right now, for simplicity, let's suppose that both of these components are positive, means the vector is in first quadrant. So I'll take x component equal to x units. So suppose this is x units. And along y-axis, it is y units. So suppose this is equal to y units. So the point can be easily located. Means the point whose coordinate is xy can be easily located simply by drawing perpendicular lines. The point of intersection will be the point whose coordinate will be x and y. So this is the vector which is xi plus yj, right? What is its magnitude? We had calculated. This is y and this one is x, right? So using Pythagoras theorem, we can write magnitude of the vector is root of x square, means square of x component, plus square of y component. This becomes magnitude. What about the direction? So tan theta is equal to p by b. So that is y by x, right? So here theta is tan inverse y by x. So from this representation, that is rectangular coordinate form representation, we are able to calculate the magnitude as well as the direction. This is what we are required to calculate from any representation. So again, this is a complete representation of a vector, right? All right, so here we are given two vectors in their rectangular coordinate form. The first vector is a vector is minus 2i minus 2j, and second vector b vector is 3i minus 4j. We have to show this vector in a Cartesian plane, and then we have to find the magnitude and direction for both of these vectors. So let's have a look. First of all, I'm going to show in fact vector a in Cartesian plane. A vector is minus 2i minus 2j, right? What does it mean? This quantity represents the x component of the vector. This quantity represents the y component of the vector. So minus 2 doesn't mean anything. Minus 2 I cap means 2 along minus I cap, because 2 is the length of that projection, that image of the vector along x-axis. So we can write it more clearly as 2 along minus I cap plus 2 along minus j cap. Now we have both the components x and y, so we can easily represent this vector in a Cartesian plane. See here, this is my y-axis and this is my x-axis, right? So here I write plus I cap, here I write minus I cap, here I write plus j cap, and here I write minus j cap, right? Now let's represent both of these components. X component is 2 along negative x-axis, so I'll draw a line of 2 units along negative x-axis. Don't mind this curve, it is, you have to assume it's a straight line along negative x-axis. Similarly, this is 2 units along negative y-axis. Now simply draw 2 perpendiculars. The point of intersection will have coordinate -2, -2, and this shows my vector, which is a vector -2i -2j, right? It's so easy. Now we have to calculate the magnitude of the vector. How to find the magnitude of the vector? So we have already done it using Pythagoras theorem. Now we can simply use the same formula, that is root of sum of a square of components. Means mod of a is root of sum of a square of components. So x component is -2 or +2, whatever you square, you'll get positive value. 2 square plus 2 square. So that is how much? Root 8. So that is 2 root 2 units. This is the magnitude of a vector. What about its direction? So we have to find this angle with respect to x-axis. This is the angle at which the vector is oriented. So for this purpose, I'll do one thing. First of all, I'll calculate this angle, this one, right? And then I'll add this one. 180 degree plus this theta, this angle, this one, will give my total angle with respect to positive x-axis. Okay, so let's find out. First of all, calculate this one. I can write tan theta is perpendicular. This is my perpendicular, which is the y component, by base. This is my base, which is x component. So simply write the magnitude, the numerical value. Don't use sign, because here we already know that this vector lies in third quadrant. So we don't need to write y component with sign upon x component with sign. Don't use sign. Simply write y component positive value, that is 2 units, upon y component, sorry, x component positive value 2 units, that is equal to 1. So that gives me 45 degree, right? But we have to see in which quadrant it lies. It doesn't lie in first quadrant. This angle is 45 degree, right? You'll have to add 180 degree in with 45 degree to get the total angle. So angle with respect to positive x-axis is equal to 180 degree plus 45 degree. How much is that? 225 degree. Now let's represent the second vector. All right, so the second vector is b vector is 3i minus 4j. Again, write it more clearly. This is x component, which is of 3 units and along positive x-axis, because it is plus I cap. Here we can write plus 4 along minus j, means along negative y-axis. What is the projection? That is 4 units. So since we know both the components, both the projections, that is along x-axis and y-axis respectively, we can easily show that vector in the Cartesian plane. So see here. So the components of the vector, first of all, the x component, this is along positive x-axis. So draw 3 units along positive x-axis. Okay. And 4 units along negative y-axis. So go 4 units along negative y-axis. Now simply draw the perpendiculars. The point of intersection will represent the point which has coordinate 3 minus 4. So this becomes my vector. Which vector? B vector. What is that? 3i plus 4 minus j, or 3i minus 4j. Simple. Now let's find the magnitude of the vector. So magnitude of the vector B vector, that is mod of B vector, is root of sum of square of components. So we can write 3 square plus 4 square. So how much is that? 9 plus 16, that is 25, 5 units. This is the magnitude of the vector. What about the direction? So before finding the direction, become alert. First of all, see in which vector, in which quadrant that vector lies. So here the vector lies in 4th quadrant. So whether you will be finding this angle or you'll find this angle, right? If you find this angle, you'll denote it with negative sign. If we find this angle, you'll denote it with positive sign. So let me go with the smaller angle. So here we can write, again we'll take positive components, positive y component upon positive x component. You don't need to write the components with sign for finding angles. You simply have to see in which quadrant the given vector lies. After that, simply calculate the angle assuming your vector lies in 1st quadrant. So I'll write tan theta is equal to perpendicular. This is perpendicular, again y component, upon base, that is x component. It is always y component upon x component. So you write y component, that is 4 units, upon x component, that is 3 units. 4 by 3, how much is that? It is 53 degree. 53 degree with respect to x-axis in clockwise sense, so you will put a negative sign. So you'll write theta is equal to minus 53 degree. Okay. Or you'll write positive this angle. How much is this? So this angle is 360 degree minus 53 degree, 307 degree. So whether write minus 53 degree or plus 307 degree. So the magnitude of the vector is 5 units and the angle is minus 53 degree or plus 307 degree, whichever you like, you can write. So in this video lecture, we have seen the representation of vectors, the symbolic representation, the polar form representation, and the rectangular coordinate form representation. In the next lecture, we will see the interconversion between these two forms of representation, that is rectangular coordinate form representation and the polar form representation. So keep practicing, keep learning, and keep growing. Till then, take care. Bye bye.